The factorial of a number is the product of all the integers between 1 and the number itself. So here you can see 10 factorial is equal to 10 times 9 times 8 all the way down to 1. What is the prime factorisation of 10 factorial, and how many zeros would be at the end of it? And if you can do that, what about extending to larger numbers? How many zeros would be at the end of, say, 200 factorial? And how can you work it out? Okay, so I love this task then because it's another nice application of prime factorisation. So we're first going to build the prime factorisation of 10 factorial. So we don't need to bother with a 1. So we're going to start with 2. So that's 1 times 2. Then we need to multiply it by 3. So we've got 2 times 3, which is 6. Now we need to multiply by 4, and a 4 is made up of 2 2's. Then multiply by 5, and by 6, which is a 2 and a 3. Then multiply by 7. Then multiply by 8, which is 2 times 2 times 2. Then multiply by 9, which is 3 times 3. And then finally multiply by 10, which is 2 times 5. So that is 10 factorial. And if you multiply those all together, you get about 3 and a bit million. It's a rather large number. The question is, though, how many zeros are at the end of it? And how does the prime factorisation help us? Well, like what we commonly do when we're teaching this topic, we often, when we're working out prime factorisations, we teach students to pull out the 5's and the 2's because that gives a multiple of 10. So the only way we're going to get a 0 on the end of this is by counting how many 5's we get. Notice that we're always going to get a lot more 2's than we do 5's here. So it's a case of counting the 5's, and that will be how many zeros at the end of it. So we've got a 5 and a times a 2 there. We've got one 10 there, 5 and a 2 there, and that's the other 10. And the rest of them, when I multiply all these together, it's going to be a massive number, but crucially it's not going to end in a 0 because it hasn't got any 5's in it. So when I multiply all them together, I get 36,000 and a bit. Then multiply it by 10, and then multiply it by 10, and you can see it's got 2 zeros at the end of it because there were 2 5's in the prime factorisation. So, what about 200 factorial then? Okay, so how many zeros at the end of 200 factorial then? Now, using the same idea as before, we're only interested really in how many 5's are in the prime factorisation of this. So we're not going to write out the whole prime factorisation, we're just going to try and figure out how many 5's would be in there. So obviously, as I'm doing the 5 times table, when I multiply by 5 and then by 10 and by 15 and by 20, all the way up to 190, 195 and 200, each of those numbers are in the 5 times table. So that's going to be 200 divided into 5. That's going to be 40 5's contributed to the total. But that's not it, because sometimes when I'm doing the 5 times table, like 5, 10, 15, 20, 25, when I hit 25, that's actually got 2 5's in it as well, because it's 5 squared. So every number in the 25 times table contributes an additional 5 to that prime factorisation. So how many extra zeros will that contribute? Well, 200 divided into 25, that will be an extra 8 5's in the prime factorisation, in addition to this 40. And then we need to consider 5 cubed as well, which is 125. There's one of those in the prime factorisation of 200. So that's going to give us an extra 1 5 there, because 200 divided into 125, there's one of them in it. Yeah, we have a remainder, but we're not worried about that. So when I do 200 divided by 125, we get 1 and a bit. But we're not bothered about that bit because it's not an extra 125. If the question had been 250 factorial, then we'd have had 2 of them. So this is how many 5's would be in the prime factorisation, 49 of them. There's obviously a lot more 2's than that, because every even number gives you a prime factor of 2 at least. So in total, we would have 49 zeros at the end of 200 factorial.